Your Academic Skills Center presents this video series to help you strengthen your statistics skills.
Hello, STAT students, and welcome to the Correlation and Bivariate Linear Regression video presentation. My name is Janine Allwright, and I am the Instructional Specialist at Walden's Academic Skills Center, where I lead the Statistics Tutoring team. In this video presentation, I will of course remind you that we are now working on inferential testing and that we're using a limited sample to answer a question about the greater population. Correlation and linear regression are related, and I will talk about where correlation ends and regression begins and how regression is truly a continuation of a correlational insight. We will talk about research questions and hypotheses for both. And like any other test in statistics, the correlation and bivariate linear regression has its own set of assumptions that I will walk through with you. And I will set up the test with an SPSS example, and we will also create a graph. And lastly, we will interpret the results and construct the regression equation. And no doubt we will tell the story of the data and address the social change component. Now let's get started. And I have this figure on the screen that you've seen before in earlier videos in this series. Our correlation and bivariate linear regression test lives firmly on the top right corner here, where the inferential statistics tests reside. This is where we use that limited sample to answer research questions about the greater population. Now, as we know, research questions can ask different kinds of questions. In the correlation and linear regression side, we do not ask descriptive or comparative questions, but we focus on questions in the relational or predictive sphere. Relational questions can be answered with a correlation. In essence, I'm using the word correlation as a synonym for the word relationship. The one variable has a relationship with the other, and the other variable has a relationship with the one. In essence, IV and DV are interchangeable. A predictive research question fits with a linear regression. Now, in this presentation, I'm going to focus on only two variables, and that fits with the bivariate linear regression. At this moment, the independent variable and the dependent variable have been selected. They are not interchangeable because one variable predicts the other variable. Let's look at an example for a correlational research question. I have an example here on the screen where my one variable is energy drink use and my other variable is alcohol-related problems. And I'm focusing on the word relationship. The alternative hypothesis will state what I'm expecting. I'm expecting that there will be a significant relationship between these two variables, and my null hypothesis will deny this relationship. And I have a similar example to set up a research question for the linear regression. I'm asking to what extent energy drink use can predict alcohol-related problems among college students. Here, the energy drink use is firmly grounded as the independent variable, and the alcohol-related problems among college students is firmly grounded as the dependent variable. They are no longer interchangeable, as we saw on the correlational side, but I'm firmly asking whether one can predict the other. Sometimes we see variations of that word, synonyms, such as impact or influence, but there's one word that I want to caution you against, and that is the word cause. Please don't use the word cause, as we do not evaluate causal relationships here in statistics. Our alternative hypothesis will state what we are expecting, and the null hypothesis, of course, will deny that. Like any other inferential test, linear regression will have its own list of assumptions, and I will name a few here. Of course, the IV and the DV are both going to be scale, and we expect that they are normally distributed. We trust that the researcher sampled in a random way from the greater population and that the scores on a variable are independent from other scores on the same variable, and that goes for the IV and the DV. In other words, we trust that the participants did not influence the results in any way. Let's look at the setup in SPSS for the correlation and linear regression. I will handle these here separately, although I'm running them both at once. It might be helpful for you to know how you would handle just the correlation part by itself. The independent variable is supposed to be scale, as well as the dependent variable. SPSS will deliver us a matrix table, and that we will interpret in 3 different ways. First, we focus on the significance to see if the relationship is significant, p smaller than 0.05. We then discuss the direction of the relationship. It can be positive or negative, or not existent. And then we will discuss the strength of the relationship, and that is actually the number of the Pearson's correlation coefficient that we will interpret for that. The linear regression is set up in a similar way. The independent variable and the dependent variable are both scale. This is a predictor relationship, and the output will be interpreted in 6 steps. We will describe the variables to share with our reader how our variables are acting in that sample data set. We will evaluate our null hypothesis with the p-value, the significance that is listed in the ANOVA result box. We will then interpret the effect size should we find significance. The effect size for regression is called R². We will then evaluate each variable individually for a sig and unstandardized beta. And we will produce a graph because we have a unique situation here where we are presenting the bivariate linear regression, and that is an awesome opportunity to create a scatter plot and show the line. And that line is represented with an equation that I will help you build. And with that, let's work with an example in SPSS. And here is the data set that I will be using to present the correlation and the linear regression. And you probably noticed that this data set looks a lot less complicated than previous data sets in this video series. This is indeed a simulated data set. It has only 2 variables on here, and it measures how many publications are produced in the academic higher ed environment based on work ethic. If this was a correlational insight, I would ask whether there is a relationship between work ethic and number of publications. But for a linear regression, I would use the word predict, or impact, or influence. To what extent does your work ethic influence how many publications you produce in a year? The correlation part of this test can be analyzed separately. I have a separate correlation option here under the Analyze button, and I would choose the bivariate. Then I can bring both my variables over in the same box, and that tells you that these variables are interchangeable here in this relationship. You can imagine if I had a lot more variables, I would get a really big list of variables here in the variable box, which explains why matrix tables, the output of the bivariate correlation test, sometimes produce these really big matrix tables. That will not be the case for us, but I will not run this separately. I'm actually going to show you that this is a one-click option that exists in the linear regression setup. I'm clicking on the Analyze button, Regression, Linear, and now my variables have to be assigned to specific boxes. My number of publications here will be my outcome variable, my dependent. And since it is the work ethic variable that will predict or influence how many publications will be produced in 1 year, my work ethic is my independent variable. When I click on the statistics button here, I can see that this has been set to a 95% confidence interval. When I click on the descriptive option here, I will actually receive the correlation output. And that tells you that SPSS is viewing the correlation matrix table more at level of descriptives. At this moment, I'm not going to engage with any other options here, but it doesn't hurt to read through them. Click Continue. Click on the Options button just because we can. We want to look around a bit. I have some other options under the Save. And of course, there are a couple of graphs that I could make here, but we will not engage with that here. We'll make a graph in a different way. Now I'm ready to run the test here. And here are my results. I can see now that I have the description of my two variables in this sample data set, and I can see that the sample size is rather small, but still the average number of publications in the year for participants on this sample data set is 8.4, and my work ethic is measured on average at 25.24. So you definitely want to describe your variables here so that your reader can engage with these variables. Here is my correlation box, and as I said, this is a matrix correlation box, and what that means is that I want to look here to see where my one variable is going to meet the other. First, I want to interpret the sig to see if there's a significant relationship. Where does the number of publications meet the other variable? When it meets itself, it will not have a number there for the sig, but I can see that there's a p-value that is rather small. And I'm going to grab back to my PowerPoint to see how we evaluate those p-values again. And here is my line. I will place that p-value in comparison to the alpha level, and we can see that on the left side here I find significance. So this is definitely a significant relationship. That is my step one in my interpretation here. My next step, as I placed on that earlier slide that I showed you, and let me refresh your memory here. The next step will be the direction of the relationship, right? I have discussed my significance already, and now we're going to look at the direction, and after that, the strength. The direction of the relationship is determined by the sign in front of the Pearson's correlation, and in our case, that is a positive number, so this direction is positive. That means when one variable goes up, the other one also goes up. It moves in the same direction. The same goes when the variable goes down. It pulls the other variable down with it. And I want to show you a slide here of all possible relationships. And here is a summary of those variations of the direction. I can have positive relationships. I can have very strong relationships. You see that in the slope of the line. When the slope shrinks a bit, I'm moving down to a moderate relationship. And when it's really very tight, it becomes a weak relationship. The same happens with negative relationships. The line will point in the other direction, but I can go from strong to moderate and weak. Please note that difference in the slope there. And of course, when I lack a relationship, I will have a straight line. In our case, I am going to compare the correlation coefficient from the output, the 0.552, to a threshold value. And we worked with threshold values for different videos and earlier videos in this series. And you can see here that the threshold values for the Pearson's correlation lies between 0.3 and let's say 0.5. So that is the guideline for the moderate effect size. Anything below 0.3 is considered weak. Anything above 0.5 is considered strong. In our case, I have to conclude that this is a strong relationship between work ethic and number of publications because the correlation coefficient came out at 0.552. Lastly, I want to mention that the correlation always shows a 1 where the variable meets itself. So the relationship between number of publications and number of publications is going to be 1. It's a perfect relationship. And the same is true for the work ethic. When it meets itself, it will have a perfect correlation. Sometimes when you see larger matrix tables and you see the ones on the diagonal, this explains why that happens. Now we can move to our linear regression interpretation here. I can see that I have my ANOVA box here. That will be the first part of our output. Let's refresh those 6 steps again on our slides so that we know exactly how to interpret the results of this linear regression. And here is that slide. First, of course, I want to describe the variables, but I already did that when I asked for the correlation. The significance is interpreted with the p-value in the ANOVA box, and the R-square comes next. If I find significance, I will then interpret the effect size. Let's take another look at the output. I have a very small p-value here. P is 0.000, or as we call it, p smaller than 0.001, because that is the proper APA way to write this up. That means that there is significance, and I will reject that negative null hypothesis. I find that there is a predictive relationship between my work ethic variable and my number of publications. At this moment, I will interpret the effect size. It is 0.305, that's the R-square. It is appropriate to interpret the R-square because we only have 2 variables, but when we move to additional variables in the future video, I will urge you to use the adjusted R-square. Additional variables will create sample differences between the one variable and the other variable, and that influences how the R-square comes out. Regardless, I have an R-squared and I will multiply with 100, with the number 100, to produce a percentage. And let me show you how we interpret this kind of R-square number. If I multiply this with 100, I get 30.5%. And for us, that means that 30.5% of the variance of our numbers of publication is associated or explained, predicted with or by the work ethic. So the R-square as an effect size tells us how much of the dependent variable really is explained by the independent variable. Now let's take a moment to learn what it means that our R-square came out to 30.5. To me, that means that that is the portion of the dependent variable that we were successful in explaining with the help of the independent variable. But if I take that number and subtract it from 100%, I have 69.5% left over. That is the part of the dependent variable that is associated with other factors, other variables. And I want you to keep that in mind and hold that thought for when you talk about the social change later on, because it is exactly what you want to mention at that moment. Surely I can explain 30.5% of the dependent variable, and that is the variable I can focus on when I want to talk about social change. But there are other factors at play here as well, which is illustrated with that 69.5%. Of course, I can also mention the threshold values here, and you can see that our R-square of 30.5% on your R-square lies on the high side here. The guidelines here are between 0.1 and 0.25, but I want to also urge you to keep in mind that research oftentimes determines what is considered strong or moderate for an R-square interpretation. But the 30.5 surely is strong. Now, returning to our earlier slide that showed us how to interpret our regression, I have now fulfilled the 3rd step, and I now want to go back to my output to interpret the variable at the individual level as opposed to the model level that I interpreted in step 2 and step 3. And here is my output again. And I will now focus on the variable here in the coefficient box. First of all, I have to evaluate my sig. And when I have a bivariate relationship, then the sig of the model determines already how my one variable is acting. But when you have more than one variable, keep in mind that you have to evaluate each variable at the individual level, because a variable can well become insignificant in a model while the model is still significant. And I will address that again in the future video about multiple linear regression. But this is a significant variable. Work ethic indeed predicts my number of publications, but I have to focus here on my 0.45, because for every increase in unit for work ethic, my dependent variable will increase with 0.45. So when my work ethic goes up with 1 unit, I will produce 0.45 more number of publications. And that part of my interpretation is also addressed on one of the slides. Let me bring this up again. And here we are. And it works like a formula. For every unit increase of my independent variable, the dependent variable will increase or decrease depending on sign with that many units that are delivered in my unstandardized beta column. And for us, that number is 0.45. So for every unit increase of work ethic, my number of publications go up with 0.45 units. Our regression interpretation is not complete yet. We still have a couple of items on the list that I showed you earlier. Let's return to the SPSS slide with that list. And here we are. We have indeed described the variables. We evaluated our null hypothesis for significance. We've discussed the effect size, and we looked at the variable at individual level, at that variable level, and discussed the unstandardized beta as well. We still want to show a graph, and from that graph, we're going to deduct the equation, and I'm going to align that with the values that you see in the coefficient table. To that end, let's go back to SPSS. I would like to encourage you to produce graphs if possible. If you have an opportunity to bring a graphical display over just the interpretation of a dry number, really, I think you should really take that. I think graphs spruce up assignments, and they are just wonderful visual displays that are oftentimes easier to interpret for students than just a number. In our unique situation here, we have one independent variable that is scale. We have another dependent variable that is scale, and that loans itself really well for a scatter plot. The independent variable goes on the x-axis, the dependent variable goes on the y-axis, and this kind of graph is really truly unique for that bivariate linear regression, because you will not have that opportunity with multiple variables on the independent side. So let's click on the graphs function here, legacy dialogues. I'm going to ask for a scatter. Simple will do. My number of publications is my dependent variable. I'm going to bring that over onto the y-axis. That's where the outcome variable will live. The independent variable, work ethics, will be placed on the x-axis. And when I run this little graph, I get my scatter plot with all the possible combinations of those two variables projected in those blue dots. I can double click inside here and ask for a fit line. I really want to see the line here, the regression line. That option, it can be found here on that lower tier of icons, add fit line at total. If you hover your mouse over that gently, it will reveal itself. So I'm putting that fit line in. I can close my property box and my chart editor. And my original graph will now have that fit line, and it gives us a present here. It shows us the regression equation as well. The numbers in the regression equation The minus 2.96 and the 0.45 should look familiar to you because they come directly from the unstandardized column in the coefficient box. SPSS has rounded this number, but this is minus 2.96. That is what we call the constant. And the 0.45 comes from the work ethic unstandardized coefficient, and you will find that back here in the regression equation. And this tells us that without even bringing the independent variable into the conversation, everybody starts with a negative 2.96, so minus 2.96 number of publications. So depending on your work ethic, you first have to work that off. That's often how we see regression equations. But for every additional unit of work ethic, however that is measured, I will increase my number of publications with 0.45 units. And this really completes the interpretation of the linear regression and the correlation here. But I still want to summarize this with you as I did on previous videos, where I show you the table and I show you which numbers are important to consider when you interpret your results. And I have these tables set up on a slide here. Here is the first table. This is the correlation output. And of course, the first table here was our descriptive statistics table. We will use that to describe our sample variables, to familiarize our readers with our variables and how they are measured and other details that are interesting. Our correlations is interpreted in 3 steps. Our first step, of course, is the p-value to assess if this relationship is significant. The second step focuses on the correlation coefficient. There is no sign in front of this number, so this is a positive direction. Both variables move in the same way. But we also want to interpret the strength, and 0.552 was deemed strong as per the threshold values that I showed earlier. Let's move on to the bivariate linear regression output. We have our model summary, our ANOVA table, and our coefficient table. The first step here is that we're going to interpret the sig, the p-value of the greater model, for significance. If this is significant, we will then move to the effect size, and that's our R-square. We multiply this number with 100%. 30.5% of our dependent variable is explained by the independent variable. And at this moment, I mentioned to keep that 69.5% in mind. We also want to evaluate our variables at coefficient level. Each variable deserves to be evaluated for significance first. And when it is significant, we interpret the unstandardized coefficient. In our case, it was 0.45. When work ethic goes up with 1 unit, the dependent variable increases with 0.45 units. We also need the degrees of freedom and the F value in order to write this up in an APA way. Lastly, I'm going to show you the regression equation and where those numbers come from. This is the line that we created. And you have the equation on the screen here, which is easy to retrieve when you make that scatter plot. But if you have more than 2 variables in your regression equation, you will not be able to generate such an equation in SPSS, and you have to write it up yourself. These numbers come from the coefficient table. The constant you see here has been rounded down. Minus 2.96 plus 0.45 times x. And of course, the x stands for the independent variable and the y stands for the dependent variable. In essence, everybody starts with minus 2.96 number of publications and will increase those based on the work ethic score times 0.45, and that is the slope of the line. I want to take you back just for a moment to that output table of the bivariate linear regression, that summary slide. And what we saw here were the values that are important to report, but I want to talk about social change now. There are two values that I want you to look at when you interpret who wants to know about these two variables in that relationship and who benefits from knowing. I think at this moment, we know that 13.5% of our dependent variable is explained by this independent variable. And at this moment, I want you to think back at that 69.5% that I mentioned that was attributed to other variables at work that influence your number of publications. While this is a very high R square, I do think that it helps to mention that because this is a singular relationship, only two variables. I think it helps to know a little bit more of what drives the publications or the volume of publications in higher ed, other than work ethic. So that is an important social change aspect. But I also want you to take a look at the 0.45, the unstandardized coefficient that belongs to the work ethic variable. And I think here we can see that if you truly want to engage with professionals in the higher ed, in the academic world that produce more publications, then it helps to hire people with a good work ethic. And I think work ethic is something that you can measure. You can measure that in the references that people provide when they are interviewed and so on and so forth. I think HR would want to know. And if publications or a high volume of publications are important to management, then you can also train people in work ethics that are already working for your organization. So again, social change-wise, think about who wants to know about that relationship between those variables and who benefits from knowing. And with this last attention to the concept of social change, this video presentation has now come to an end.
Thank you for watching this video presentation. If you have course-level statistics questions, reach out to our stats tutors at statsupport@mayo.waldenu.edu or view our statistics support resources at academicskills.waldenu.edu.